So our second speaker of this session is Vishal Shrivastav from the Institute of Physical Chemistry of the Polish Academy of Sciences. And he's going to talk about metal organic framework derived nanosized metal nitrides in carbon framework for energy storage applications. So let's welcome Chef.
Hello everyone. So as you know, my topic of today. So let's talk about supercapacitor first. Supercapacitor basically are the energy storage devices. Just like battery, it store energies. But unlike batteries, batteries store charges like intercalation and deintercalation of ions in the electron material. But supercapacitors work on the adsorption of electrolyte ions in the electron materials. And regarding to that, we should have some basic qualities in the material, like it should have high surface area to absorb the maximum amount of electrolyte ions. It should have high conductivity to pass on the electrons, as well as the size of the materials also matter. Like if we have nanomaterials that can show higher capacitance compared to the bulk, as well as the properties of the material that showing battery-like behavior can be tuned to the supercapacitor type behavior by changing the size of the material. So having all these properties, we can find metal organic framework as suitable material. Like metal organic framework, basically it is a 3D framework of metals and organic linkers. We can combine different organic linker and metals to make a 3D framework structures. So it has high surface area and flexibility to control pore distribution, basically based upon the use of organic linkers. However, there are some downside of metal organic framework also. Like it has low electrical conductivity and low redox activity. So what is the solution? We can produce different products from MOF by keeping its frameworks. Like we can produce redox active products, oxides, sulfides, phosphides, or we can produce carbon also. Just we can paralyze the MOF to produce metal doped carbon, and after that we can remove the metal to produce a carbon structures. Or else we can combine redox active product and the carbon to produce a composite material like nanosized redox active material in the carbon framework. So in my work, what I have done, I have used GIF67 MOF, which is a combination of cobalt metal and 2-methyl imidazole framework. I have produced cobalt doped carbon firstly through pyrolysis method, and either we can produce metal-free carbon by HCl washing, or else we can react it with the ammonia gas to produce cobalt nitride in the carbon structures. So this is the TEM image of the material. We have produced cobalt nitride, nanosized cobalt nitride in the carbon framework, and the XRD shows the peaks of the cobalt nitride. After that, we did the electrochemical studies of the material. Basically, firstly, we have optimized the electrolyte. For 6 molar KOH, we got the lower Coulombic efficiency. And for the lithium sulfide, we get lower capacitance. So we have optimized the lithium hydroxide for this material. And we did the CV and the GCD. And from GCD, we got 320 farad per gram of capacitance at when we discharge it at the rate of 1.5 ampere per gram. We also compared this with the bulk cobalt nitride and the material we have prepared, and we got the higher capacitance when it compared with the bulk cobalt nitride. And thank you very much for listening. And any questions? I think it was very quick.
So questions for Vishal? I'll start with one. So you're showing here muffs with cobalt, which is both toxic and not very abundant on Earth and expensive.
Yes.
Are there other metals that you can use, and why have you been using cobalt?
Basically, we are working on different metal organic framework. We are also working on zinc-based MOF also, and manganese-based MOF also. And I'm just showing the only GIF67. We are also comparing this with
And what's
other
the advantage
MOFs.
of cobalt?
What?
What is the advantage of cobalt?
It is the redox activity with the lithium ions. So this is the advantage of the cobalt nitride.
Okay.
But we are also working on the zinc sulfide doped carbon also, and the other like manganese oxide doped carbon, and the other products of the metal organic frameworks.
Okay, thank you.
Thank you.
Yes, please. Please use the mic.
Hello, very nice talk. Firstly, can you please explain why the capacitance of your cobalt nitride is more than the bulk cobalt nitride?
Basically, by reducing the size, we can increase the surface area of the material, and the higher surface area can give the more electrochemical activity as compared to the bulk material.
So basically, the cobalt nitride derived from the MOF has more surface area as compared to the normal one, or the pure
Yes,
one.
cobalt nitride got from the metal organic framework has the much nanorange size as compared to the bulk, and it will not aggregate like the other bulk material because it is in the carbon framework structures, so it is also beneficial.
Okay, thank you.
Is there another question? If not, let's thank Vishal again.
Thank you very much.